Hi, and thank you for joining me for another in a series of videos where I've been building experiments from this book, which is Charles Platt's Make Electronics. Now today the book introduces us to a very important aspect of electronics, which is that every moving electric charge also creates a magnetic field. So let's start by showing that that is indeed the case.
So what you're looking at here is an electric cable which is currently feeding an electric heater. So this is drawing a fair bit of current because we're talking about a 1 kilowatt heater here. This is a meter that is currently measuring the magnetic field in terms of milligauss. And what you'll see is if I turn this now to point to the cable, you can see that we're now getting a much higher reading than we were for the ambient level of 23.8 milligauss. Now you see that this meter is indicating this is high, and indeed it is high for a milligauss reading from an electric cable. But if I was to tell you that a fridge magnet will generate a reading of about 50 Gauss, and here we're talking about milligauss, not Gauss, milligauss, so a much smaller unit, you can see that the magnetic field being generated by the cable is actually quite small. Okay, so what I've got here is this, which is a typical kind of fridge magnet, sort of thing that you'd buy in tacky tourist shops. By the looks of it, this one is from Berlin, judging from the rather awful rendition of the Brandenburg Gate on it. But that's beside the point. The main thing about this is that the reverse of it has a permanent magnet. So that will always have a magnetic field. And that can be used to attract materials that are ferromagnetic. Which means that they are attracted to a magnetic field, and we can see that if I move the fridge magnet over these metal paper clips, you can see that they are sticking to the magnet as you'd expect. And then here I also have an Allen key, and as you can see, if I put the Allen key onto the magnet, then that is also attracted by that magnetic field. It's quite a weak magnet, this one, so it doesn't hold if you move it around too much, but you can see that that magnetic attraction is there. But these two things, the paper clips and the Allen key, do not in themselves have a magnetic field. So as you can see, if I try and lift the paper clips with the Allen key, nothing is happening there. But you can also see what I have here is some ordinary electrical wire. This is just stranded wire with a stranded copper core. It's quite a lightweight wire. It's exactly the sort of wire that we would use in a low voltage DC circuit that we might power with a 9-volt battery, say. Now the question is, can we use an electrical current through this wire to create a magnetic field sufficient to lift these metal paper clips? The problem is, of course, that as we've seen, even with a fairly hefty cable carrying 240 volts AEC and connected to a 1 kilowatt load, the level of the magnetic field was still very tiny in comparison to what you would get even from a tiny little fridge magnet like this. So what hope have we got of generating a sufficiently large magnetic field from a tiny little cable with a 9-volt supply? Well, the solution is that there are two things we can do to amplify that magnetic field. One of those is that we can coil this wire together with very tight turns, and that will serve to amplify the magnetic field running through the coil. But what will make this even more effective is if we use that coil to induce a magnetic field in a core, and that core can be any ferromagnetic material. So this Allen key will actually serve quite nicely to do that. So what I'm going to do is, you can see there is a mark already on this Allen key. I'm just going to use a ruler just to measure out 2 inches from that mark, and then I'm going to just cut a small piece of electrical tape and just use that to mark the other extent of that 2 inches, and you'll see why in a moment. Now I'm going to take my wire, I'm going to allow a little bit at the end for making a connection, and what I'm going to do is I'm just going to tape it so that it emerges from where that electrical cable is, sorry, where the electrical tape is, I should say. So I'm just going to cut another piece of tape, if I can get the end, which does not want to come. There we go. Just to secure this in place. So just allow a little bit of length and just pop that tape over to secure it. There we go. And now what I'm going to do is to start winding the wire with very tight turns around the Allen key. And as you can see, I'm keeping those turns, might be a little bit difficult to see with the black on the dark Allen key, but I'm keeping those turns very tight so that they're right next to each other. And what I'm going to do is I'm going to carry on doing this until I've created a 2-inch long layer up to this silver mark, and then I will start winding back in the other direction, and I'm going to keep doing that until we've got over 100 turns in that space. So I'll just do that now, and then we'll pick up and see what that gives us. So here's the finished coil. As it's not particularly tidy, but it's good enough to do the job. And as you can see, at the moment we've got the Allen key right next to the sensor in the meter, but we're not recording any magnetic field whatsoever. However, if I now connect the battery up, let's see what happens. And look at that, immediately that magnetic field increases, and let's see if it is in fact sufficient to lift the paper clips. And there you go, there are the paper clips attached to that. So what we've effectively done there is to create an electromagnet, and that is the principle by which electromagnets work. I have disconnected it fairly quickly, because one thing to watch out for with crude electromagnets like this is that it will draw quite a high current, and if you leave it connected for too long, things will start to get a little bit warm. So it's best to just do it briefly enough to demonstrate the principle and make sure that you don't leave it connected and potentially start a fire.
So the relationship between an electrical charge and a magnetic field is fascinating, and indeed we are going to continue to explore that for a few more experiments. And one thing you might have been wondering is, okay, well, if a moving electric charge can create a magnetic field, is the opposite also true? Can a magnetic field create an electric charge? Well, please join me for the next video to find out.